Good day, grade 12 learners. Welcome to our today's lesson in Chemistry Physical Sciences. My name is Thandwe Uwane. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center, broadcast by Phakama Research and Development. As you know that this is our live lesson, you can interact with us on our WhatsApp number, which is 064 748 8913. Now, as you know that the lesson that we are doing today is the continuation of our previous lesson. So what I want you to remember from our previous lesson is that we need to remember all the homologous series. How do we identify them? Understanding that they are having different functional groups and be able to identify them using their different functional groups. So today's lesson will be based on organic reactions. However, it is not going to be easy for us to understand organic reactions if we are unable to understand different homologous series using their functional groups and how they are structured in different compounds. Now, we are going to start by looking at the following. For us to easily understand these reactions, I have tried to come up with different strategies that will assist us in terms of identifying the reactions and know what are the expected products when we have certain reactants in our reactions. Therefore, the first thing that I want you to remember, I want you to remember what do you mean by saturated and unsaturated compounds. I think in the previous lesson, we looked at the different definitions, and these two definitions were part of the previous definitions, whereby we said saturated compounds are compounds whereby there is only single bonds, and unsaturated is when they have multiple bonds. So we are going to further try and classify different homologous series or different compounds using looking whether they are saturated or unsaturated. The ones that are going to be stipulated for the purpose of this lesson, they are the ones that we are going to look at when we are going to do our different reactions. Therefore, the saturated compounds that we are going to look at when we are going to do our different reactions are going to be alkanes, haloalkanes, alcohols. Those are the saturated compounds that we are going to deal with, or that we are going to look at when we are looking at different reactions. And then our unsaturated compound, we are going to look at alkenes. Remember, alkenes is not the only example of unsaturated. Even the alkenes are not the only examples of saturated. However, we are going to use them for the purpose of this lesson so that we can also use our strategy according to our exam guideline. Because our exam guideline will always stipulate which type of reactions are we going to do, and also which compounds are we going to use for those different types of reactions. So always remember that when you look at the alkanes, the haloalkanes and the alcohols, you are classifying them as saturated we are classifying them as saturated carbon compounds, whereas alkenes, alkynes are classified as unsaturated. For the alkynes, as they are not part of our classification in this specific lesson, is because alkynes are not going to be part of our examination in terms of the reactions. They are not going to be formed as part of the product, and they are not going to be acting as the reactants. That is why I just decided that alkynes, we are not going to discuss the reaction of alkynes, but for the unsaturated, we are going to discuss the reactions of the alkenes. Now, how will these saturated and unsaturated compounds assist us in identifying different types of reactions? There is this strategy that we are going to use of these alphabets that we are going to use to determine the type of reaction that we are going to discover, or that we are going to get at the end when we have saturated and unsaturated compounds. Now we are going to use a strategy of triple S and then SU USA. What does triple S SU USA mean, and how can it assist us to identify different types of reactions? Let's start with the first one, which says triple S. In terms of triple S, especially when you are given a flow diagram, when you say S, the first S means saturated. When you have a saturated reactant and it provides you a saturated product, it means the type of reaction that you are going to get is a substitution reaction. So the first alphabet, triple S, stand for saturated, giving you saturated. the type of reaction will be substitution. The second one is going to be SU, whereby we have saturated. When an unsaturated product is formed, you will definitely know that that type of reaction is elimination. So SU means saturated to unsaturated provide you elimination reaction. Remember, learners, this will assist you, especially when you can be able to identify those compounds as saturated or unsaturated. Then the last one is when you have an unsaturated compound and the product that you're going to get at the end is going to be saturated and the type of reaction is addition. What is important is that this is the slide whereby you need to always remember what do you mean by saturated, what do you mean by unsaturated. For the unsaturated compounds, because we are only going to deal with alkenes, it means that always when you have your alkene as a reactant, what you are going to get at the end, you are going to get all the saturated, meaning that the alkenes will always undergo addition reaction. Now, let's look at this activity and see whether we can be able to use our strategy of triple S, SU, USA, in order for us to determine the type of reactions that can be provided to us in order to be able to say whether the reaction is addition or elimination or substitution. Now, if you look at the activity, the first thing that you need to do, you need to identify your compounds as provided on the table, whether as saturated, unsaturated, in order for you to know what type of a reaction are you going to get. And also, we are going to follow the arrow. If the arrow is coming from saturated, it means our saturated is going to be our reactant. And when it is going to a product, we are going to look whether that product is saturated or unsaturated. For the example that we are provided here, now we are going to use this and see whether we can identify the following compounds as saturated or unsaturated. Before you can even think about the type of reaction, identify them first as either saturated or unsaturated using the list that I provided on my previous slide. So when you look at compound P, you can see that compound P is an alcohol. The next thing that you check is whether the alcohol is under the saturated or the unsaturated. And if you look back at the list that we have provided on our previous slide, you can see that alcohol is going to be saturated. Then if alcohol is saturated, the alkene that is provided on compound 1, you will know that it means alkene is unsaturated. You just identify them first before you can start identifying the type of reactions that will be formed by each process. Then you go to the 2-chlorobutane. We know that chlorobutane, as we were even naming the hydrocarbons in our previous session, we know that chlorobutanes are alkanes which have halogens. So they are classified as haloalkanes. And if they are classified as haloalkanes also fall under saturated compounds. Then the last one, which is going to be the butane. Butane, if you look at butane, you can see that butane is also an alkane. Therefore, it means butane falls under saturated. Then after identifying them as either saturated or unsaturated, that is then you are now going to identify reaction A, B, C, D, and E. How do you do that? You will firstly look at the first one, compound P. We said compound P is saturated. So for reaction A, if you look at reaction A, is from a saturated compound and it is forming an unsaturated compound. So when you go back to your strategy, from saturated to unsaturated, it means it's going to be our SU. So if it is SU, it means it is from saturated to unsaturated. Therefore, the type of reaction is going to be elimination. So it is easy when you can be able to firstly identify that compound as saturated or unsaturated before you can go and choose your reactions. Then when you look at B, B is from unsaturated to saturated, meaning that it is from an alkene which we have classified it as an unsaturated, even though we don't know the name of the alkene as compound Y, but we know that the homologous is alkene and alkenes are unsaturated. Therefore, it means as the arrow is moving from the unsaturated alkene to the saturated compound P, which is, we have identified it as an alcohol. We know that it means reaction B now is going to be addition reaction. So this one is from unsaturated to saturated, then our reaction is addition, meaning it's our USA. Then when you look at reaction C, you can see that reaction C is moving from the saturated compound to the saturated compound. So we know that when we move from saturated to saturated, we are using triple S. So saturated to saturated, it means our type of reaction that we are going to get for reaction C is going to be substitution. Then you can also think about reaction D. Reaction D for us is provided as from 2-chloropropane, 2-chloroputane, which is saturated, and it goes to alkene compound Y. So for reaction D, you can also be able to identify the type of reaction that can this the reactants undergo to form that product. So it's from saturated and it goes to unsaturated. Therefore, we know that if it is from saturated to unsaturated, it means it's our SU, and the type of reaction that this D will undergo is elimination reaction. The last one that we are going to look at is E. When you look at reaction E, you can also see that reaction E is coming from unsaturated compound to saturated compound, and we know that the type of reaction will be addition. Now, I think we can conclude from this a strategy to say, always when the arrow is coming from an unsaturated, which is an alkene, the type of reaction that you are going to get is addition. So it means always our alkenes will undergo addition reaction according to the ATP and our exam guideline. Because as we started this lesson, I said to you, we are not going to look at the reactions of alkynes, whether as products or as reactants. So you'll know that always when you see an alkene undergoing any type of reaction, that type of reaction must be an addition reaction in terms of our exam guideline and our ATP. So I hope learners, by using this strategy of triple S, SU USA, the first thing that you are going to be able to do is to identify the reaction. And identifying the reaction will also assist you to go further and identify the products and the reactants. Now, as I said that we are going to look at whether the compounds are saturated or unsaturated, it is very important to understand also how are we going to test for saturation as one of the reactions that we are going to do as part of our ATP and our exam guideline. So testing for saturation is very important because you need to know whether a compound is saturated or unsaturated. Now, I started by providing a little definitions of saturated and unsaturated, whereby saturated compounds with single bonds only. And learners, you must know that this word only is very important here, because some of the unsaturated, they still do have single bonds, but not only single bonds are in that compound. So therefore, you need to put the word only single bond in a compound or single bond only, so that you show that there is no way that you can get a double bond in that structure or in that compound. And then we said unsaturated have multiple bonds. Double bonds, triple bonds, they all qualify for unsaturated. But for this lesson, we are going to look at only the alkenes as unsaturated, because we are only going to look at the reactions where alkenes are formed or where alkenes react. Now, what do we do, or what do we use to test for saturation? We are going to understand that in terms of testing for saturation, we are going to use what we call bromine water. The color of bromine water is orange-brown in color. Now, how will the bromine water react in an alkane or in a saturated, or react in an alkene which is an unsaturated? Because we are going to use our alkanes and our alkenes to test for saturation. We know that alkanes fall under saturated compounds, alkenes fall under unsaturated. Therefore, if you put bromine water inside an alkane, if you make alkane to react with bromine water, the type of reaction that you are going to get there is a substitution reaction. Now, what is it that will tell you that substitution reaction has taken place? If the color of bromine water doesn't change instantly, especially if you are doing the two reactions in a dark room, if the color of bromine water doesn't change from brownish orange to colorless, it means substitution reaction has taken place. Therefore, that specific compound is an saturated compound. But if you pour bromine water in an unsaturated compound, the color of the bromine water will change from orange brown to colorless. What is happening in that reaction? We know that I said to you, alkenes will always undergo addition reaction. So what changes the color of bromine water is during the addition reaction. Now, how does this occur? Let's look at different alkanes and alkenes. What exactly is happening when we are undergoing a substitution reaction of alkanes and when we are going an addition reaction of alkenes using bromine water? We know that bromine is element in group number 7 and is a diatomic element, so it's always written as Br2. Now, Br2 will react with an alkane and Br2 will also react with an alkane. Let me take an example of propane. Propane, we know from the naming of hydrocarbons, is going to have 3 carbon compounds. As propane is having 3 carbon compounds as their longest chain, it will have what? It will have hydrogens. Remember, this is a saturated hydrocarbon. There are no triple bonds or single bonds in it. Therefore, when it reacts with bromine water, now we must undergo substitution reaction. We will still look at substitution reaction into details, but this one is just to show you how will a substitution reaction occur when alkanes react with bromine water and also when alkenes react with bromine water. Then it means now we are going to look at our carbons that are having different hydrogens. We have carbon number 1. We can say this is carbon number 1, number 2, and number 3. When you look at carbon number 1, number 2, and number 3, we must make sure that we substitute with bromine water. However, bromine, we know that in a structure is Br and Br. So how do we make substitution? We are going to look at the 3 carbons, the 3 carbons in a chain. When you look at carbon number 2, you can see that carbon number 2 is having 2 hydrogens, whereas carbon number 1 and carbon number 3, whereas it can also be carbon number 1 in terms of our naming of compounds. You can see that these 2 carbons, they have 3, whereas carbon number 2 is having. So if you need to substitute, we always look at the one with the least number of hydrogens. This method, we are going to use it when we do addition reaction. We're going to look at the number of carbons that each carbon have in order to substitute, in order to add, or in order to eliminate. So when you understand the substitution that I'm going to do now, it's going to be easy when I'm going to further do the substitution of every compound into details which are saturated. Now, what we are going to do, the first carbon will not be able to be substituted because it's having a maximum number of carbons. However, when you look at carbon number 2, we can decide to say, okay, in carbon number 2, we substitute with 1 bromine atom from Br2, which is a diatomic atom, a molecule. Then, if we have substituted already in a compound, we don't have to substitute it twice because we can't substitute twice because this one is having a maximum number of hydrogen. Therefore, what will happen, this hydrogen here is being substituted with the bromine on the other side. And what will be formed? From this alkane, as we are going to do this substitution reaction, you will find that a haloalkane will be formed. And if the haloalkane is formed, what will happen to the other hydrogen? Remember, this hydrogen was substituted. It must go somewhere. Remember, the atoms cannot be lost nor created in a reaction. We know that we must always compose the matter. We must always do the constant composition of matter from the reactant side to the product side. And we must always make sure that our reaction is balanced. So what is going to happen is that the hydrogen that was substituted on the carbon number 2 is going to react, or is going to combine with the bromine that never substituted in carbon number 2 on the haloalkane that was formed. And the inorganic molecule compound that will be formed is going to be our HBr. So our HBr, our hydrogen bromide, is our inorganic product that will form when a substitution reaction occurs between an alkane and bromine water. But remember, this is still what we are using to test for our saturation. We are not yet in different types of reactions. Then when you look at, we are going to use propene. Propene, remember, is having double bond, is an alkene, and then it's going to be, always make sure that the number of carbons, the number of bonds around carbon is always 4. So we are going to check the first carbon is going to be 1, 2, 3, 4. And then this one is already having 3 bonds already by introducing this double bond. So it means it's going to be 1, 2, 3, and then 4. And then we put another hydrogen, and then hydrogen, hydrogen, and a hydrogen. So if you are going to do addition reaction with bromine water, now in terms of the alkenes, in terms of addition reaction, immediately when you are doing addition reaction, you know that there will be a double bond in that compound. Therefore, what do? We are going to break the double bond, which affects carbon number 1 and carbon number 2. So it means we are going to make sure that carbon number 1 and carbon number 2 do not have a double bond anymore. So the hydrogens that were in carbon number 1 were only 1, 2. And then it means if I break this double bond, it means I will now have a missing bond which needs to be added something so that it can occupy the properties of carbon, because carbons need to bond with 4 things. Then the next one, it was having a hydrogen. However, now there is also another missing bond. The third one, it was fine, it was having 3 hydrogens. Therefore, it means now the bromine water must be added in a compound after breaking the double bond. So we are going to add bromine water here and bromine water here. And what you're going to observe is that when you do addition reaction, especially using a diatomic element, a molecule like bromine water, everything is going to be added at once. When you look at our substitution reaction that occurred, we had 2 products where we had one of the organic product and the other one was inorganic. However, when we are doing the addition reaction where we are adding bromine water in an alkene, we have seen that both the atoms of bromine are added in that reaction because we have broken the double bond that was between the alkenes. So this is the reaction that is, this is what makes the 1,2 dibromopropane, because we now know how to name the structures. This one we know is going to be 2-bromopropane. However, this one is going to be 1,2-dibromopropane. So it means the color of 1,2-dibromopropane can instantly change the color of bromine water. The color of 1,2, it shows that bromine water is added. So the colorless, what makes the bromine water to be colorless is the formation of the 1,2-dibromopropane. Whereas when 2-bromopropane is formed, the color didn't change instantly. However, if you keep this reaction of substitution, the first substitution reaction, in light as one of the conditions that will affect the reaction, the color of bromine water will also change to colorless. So it means you must make sure that one of the conditions to make the test of saturation between the alkanes and the alkenes or any other saturated or unsaturated hydrocarbon, make sure that you do this experiment in a dark room so that your color is not affected by light, which is one of the conditions that will influence the substitution reaction. So this is how we are going to test for saturation using bromine water. So sometimes the examiner will ask, how do we test for saturation? You know that you are going to use bromine water to test for saturation. Now, let's go to different types of reactions. In terms of different types of reactions, we are going to look at oxidation reactions. They are sometimes calling it combustion reactions. However, for the oxidation reactions, we are only going to look at the oxidations of alkanes, because the alkanes are the ones that are examinable for combustion reactions. And then we are also going to look at the esterification reaction. This is the reaction whereby an ester will be formed by primary alcohols, as we explained what are primary alcohols in our previous lessons, and carboxylic acids. So esterification is one of the reactions that we are going to look at in terms of how are esters formed using alcohols and carboxylic acid. Then we are going to look at addition reactions, as we have already started with some of the examples of addition reaction using the previous example of test for saturation. So I said under addition reactions, you must know that only alkenes will be examinable, meaning that you must know that always our alkenes will undergo addition reaction. Then we are also going to look at elimination reactions. For the purpose of the exam again, the elimination reactions are only going to be undergone by the saturated compounds. And immediately when I say they will be undergone by the saturated compounds, you already know that saturated compounds I refer to alkanes, haloalkanes, and alcohols according to the list that I provided in our previous slide. And then substitution also, we are also going to look at the substitution of saturated compounds, whereby we move from saturated compound to another saturated compound, meaning that always when you see an alkane forming a haloalkane or an alcohol, you must know that is substitution, or a haloalkane forming an alkane or an alcohol, you must know that is substitution. And also alcohols forming haloalkanes and alkanes, it is also substitution reaction. So all of them, as they will be undergoing elimination reaction, they will all, if they are undergoing elimination reaction, they will all provide what we call alkanes. Therefore, you won't have any challenge in terms of identifying what type of a reaction is this. You will just check whether it falls under saturated or unsaturated, and you'll know that always when an alkene is formed as part of the product, because sometimes an alkene cannot be formed alone as part of the product, but it will be part of the product, you must know that that type of reaction, it is elimination reaction. Therefore, these are the reactions that we are going to look at today, and we are going to try and explain them further in terms of how they undergo. So the first one that we are going to look at is oxidation reactions. These are the reactions of alkanes in excess oxygen. The reason why I put excess oxygen is because sometimes you can do these reactions and you find that your oxygen is insufficient. When it is insufficient, definitely you are not going to get carbon dioxide. The product that you're going to get in terms of the gas that is formed as carbon dioxide is not going to be carbon dioxide, but it's going to be carbon monoxide. Our exam doesn't do oxidation reaction of insufficient oxygen. It only looks at excess oxygen. So what are the expected products in terms of oxidation reactions? We will always expect carbon dioxide and water to be formed. So always when you are reacting alkanes or alkenes or other compounds with excess oxygen, you are going to get carbon dioxide and water. However, our examination will only be limited to alkanes, whereby only alkanes will be examinable and will react with oxygen, and then what we are going to get is carbon dioxide and water. Now, these are a few examples that I want you to look at in terms of how do you do oxidation reactions. You must know again that oxygen, just like bromine, is a diatomic element. As a diatomic element, I think we already know by now, starting from grade 9, that there are 7 diatomic elements, and when they react like that in nature. Those examples are hydrogen, nitrogen, oxygen, fluorine, iodine, bromine, and chlorine. 1, 2, 3, 4, 5, 6, 7. So these elements, they react as diatomic in nature. When I say I add oxygen, I cannot write O. The first thing that I must remember, I must know that oxygen is a diatomic element. And if I want to write oxygen, I must write it as O2. So that is why when you see these compounds reacting with oxygen, you can see that the first example is methane reacting with oxygen, which is O2, to give you what? Carbon dioxide and water. Now, what might be the challenge in this type of questions? The only challenge that we might have the problem in terms of the challenge in terms of balancing these reactions. And what makes this to be a little bit a challenge to balance is because of this diatomic element, which is oxygen. So I'm going to take you through a certain method on how can you easily balance these oxidation reactions without any hassle. Like when you look at the first one, you can see that we have methane plus oxygen giving you carbon dioxide and water. Now the strategy that I'm going to use, I want you to write it exactly as it appears on the slide. You will start with an alkane, follow with oxygen. In terms of your products, you will start with a carbon dioxide and then follow with water. So these are the extending products that will be formed during the oxidation of alkanes. Now let's see how can we be assisted in terms of balancing of these reactions. Let me take alkanes, which was the first example. Alkanes we are going to use our general formula, of course, to know how do we write the molecular formula in terms of finding the number of hydrogens, because it is easy to find the number of carbons. Let's take methane. Methane reacts with oxygen to give us carbon dioxide, as I said, and water. Now, how do we then balance this equation? Now, you can see that methane is having 1 carbon. So, when we balance it, we are going to take the 1 carbon of methane and put it on the carbon dioxide side. And the number that follows 1 is number 2. Now, we are going to find the number of oxygens on our product side and take the number of oxygens on our product side and divide by 2 and balance the number of oxygen on our right hand side. Now, on our left hand side. Now, let's look. 1 times 2 is 2. 2 times 2 is also 2, meaning that we have 4 oxygens on the side of the product. What is a half of 4? A half of 4 is 2. Then, after putting these 2 here, we are going to check whether our equation is balanced. How many carbons? 1, 1. You know that the number 1, we normally don't put it in our balancing of equations, because we know that if something is 1, there's no need to say 1 car or 1 cow. If you say a car, I already know it's 1. But if you say cars, I will ask how many, then you can say the number. So it's just carbon dioxide. You don't say how many molecules or how many moles of carbon dioxide are there or are present in this reaction, because it's only 1. So we have 1 carbon this side. Hydrogens, there are 4 this side, 2 times 2, there are also 4 this side. So they are also balanced. Oxygens, 2 times 2, 4 this side. We have also seen that when we're trying to balance, we find that is 2 and 2 times 2 is 4. So our equation is balanced. We can go to the second one. Let's say ethane. Ethane is C2H6 according to our general formula. We are going to make it to react with oxygen to give us what? Carbon dioxide and water. Now, because ethane is having 2 carbons, it means now we are going to take the 2 and put it here. What is the number that follows 2? The number that follows 2 is 3, and we are going to put it next to water. Now we will try and balance the number of oxygens on our right hand side. Now it's going to be 2 times 2, which is 4, and then 3 times 1, which is 3. So 4 plus 3 is 7. And then we are going to now find the half of 7. So the half of 7, we can write it as 7 over 2. However, we know that when we balance equations, we must not put them as fractions. Therefore, we need to remove these 2. How are we going to do it? We are going to multiply by 2. We are going to multiply everything by 2 so that we can remove these 2 as a fraction. So it's going to be 2C2H6 plus 7O2 give you 4CO2 plus 6H2O. And if you are going to look at the number of atoms in from the right to the left, you will see that the number of atoms are balanced. The next one, I can just use maybe propane, which is C3H8, which is the last example that I'm going to use, giving us carbon dioxide and water. So if you use propane, it means it's going to be 3. So it means here we are going to put what? This is 2. We are going to put 3. The number that follows 3 is 4. Therefore, we are going to say 3 times 2 is 6. 4 times 1 is 4. 6 plus 4 is 10. What is the half of 10? Is 5. So if you can look at my examples, you can see that when I'm using odd numbers like 1, 3, 5, 7, it's going to be very easy for us to balance the two sides, because we are going to get the even number on the side of the product, and then it's going to be easy to divide by 2. However, if you are having an even number like 2, 4, 6, definitely at the end you will be compelled to multiply by 2 to remove the fraction. So this is another strategy that you can use to balance these oxidation reactions. So we always know that oxidation reactions will involve the alkanes and oxygen to provide you carbon dioxide and water. Now, these are some of the uses of alkanes. We use alkanes for the gas stove heating. We use alkanes for the cigarette lighters. We use alkanes for the petrol. So you need to also know the uses of alkanes, because they are also part of your exam guidelines. These are just few examples that I've just chosen for you to know that where do we use our alkanes in our daily lives. Even our petroleums and other things, they are coming from alkanes, our vaselines and other stuff. Now, esterification. This is the formation of esters using carboxylic acids and alcohols. The first thing that you need to know that the primary alcohols are the ones that we are going to use to form our esters. I think here we need to have a double bond, and also here a double bond, because this is a CO bond for carboxylic acid and also the esters. Now I'm going to just quickly look at one example whereby we are going to form an ester. I normally say, we know that, let's say we use a propanol as our alcohol, which is having one which is a primary alcohol, and then we make it maybe to react with, what? Maybe with propanoic acid. Then I'm going to write my propanoic acid in this fashion, so that for the purpose of this lesson, so that my CO bond is next to the OH, because these are the two bonds that are responsible in there's no bond here. These are the two bonds in terms of the formation of esters. Now, in terms of this, some books are saying the H, I'm going to take it from the alcohol, the OH from the acid. Some are saying, so it doesn't matter. But what you must know is that at the end of the day, when esterification reaction occurs, water is going to be one of the product plus an ester. So if I take the H from the alcohol and the OH from the acid like this, it means they are going to form H2O. So H2O is going to be one of my product that is going to be formed. Now, what will be the ester that will be formed? I'm just going to combine my structure, meaning that I'm going to put my CH3 like this, followed by CH2 like this, followed by CH2. Therefore, because the H is gone, what is left is the O and then dash. Here the OH is gone, what is left is the C. So it's C double bond O and then H, H, C, H, H, H. So this is going to be the ester that will be formed from propanol and propanoic acid. So how do we name the ester? I always say this oxygen is my boundary, is my barrier. It will separate the side of the alcohol and the side of the acid. How do I know that this is an acid? Is because of this. We don't have such in an alcohol. We don't have CO bond in an alcohol. So already I know that this is coming from a carboxylic acid. Therefore, my alcohol will form an alkyl and my carboxylic acid will form an OH side. So what will be the name of this? My alkyl will have now 1, 2, 3 carbons. So this is going to be propyl. And then there are 1, 2, 3 also propanoate. So propyl propanoate is formed from a propanol. And remember, we will always use primary alcohols. I hope this example will assist you in terms of identifying esters and also forming esters. But this reaction cannot occur if we don't have a catalyst. So what is it that we need for this reaction to really occur? Because it can take years for that alcohol and that carboxylic acid to react. We need sulfuric acid. So H2SO4 is one of the conditions. And H2SO4 is going to be concentrated for us to find this reaction. So we are going to use concentrated sulfuric acid as a catalyst. I think we know what is a catalyst by now from grade 11, we know that it speeds up the reaction. It makes the reaction to be faster. So propyl propanoate is going to be formed in the presence of sulfuric acid as one of the conditions which is concentrated in order for esterification to occur. So always know that the catalyst sulfuric acid is very important for the reactions of esterification, because it's the one that will make sure that these reactions definitely occurs. So we have already looked at oxidation reactions, which is the reactions of alkanes and oxygen. Now we have looked at esterification, which is the reaction where esters are going to be formed, whereby we are going to have alcohols and carboxylic acid. But make sure that you know that the type of alcohols that we are going to use for the purpose of these reactions and these lessons are always going to be our primary alcohols. Now, these are different types of addition reactions. I think we already know by now that addition reaction, we are going to see a double bond being broken in order to add what we are going to add. So it is very important to know which addition reactions are we going to do. We are going to look at 4 types of addition reactions for our syllabus. We are going to look at the addition reaction, whereby we are going to look at hydrogenation. Hydrogenation, we are expecting to get our product as alkanes. Now, if we are doing addition reaction, we know that an alkene will be involved. We know that always it will be an alkene that will undergo that type of reaction, because a double bond must be broken. So it means during hydrogenation, the alkene will add something and the product will be alkanes. So we are expecting during hydrogenation to find alkanes as product. We are also going to have halogenation, whereby we are going to find haloalkanes. But during halogenation, our haloalkanes will have 2 halogens. And then we are also going to have hydrohalogenations, where we are also going to find haloalkanes. But in hydrohalogenation, our haloalkane will have only 1 halogen. And then we are also going to have hydration, whereby we are going to look at addition, and then the product will be alcohols. What is it that we need to add? During hydrogenation, as I said, is when we are going to add a hydrogen in an alkene to form an alkane. I think by now we know hydrogen is a diatomic element. That's why we write it like this. So it means during addition of hydrogen in an alkene, this is an example of addition reaction of an alkene, whereby hydrogen is going to be added. So we are taking an ethene, CH2, where there is a double bond, and then we are adding hydrogen, and when we are finding ethane, and we know that this is ethene is unsaturated, this is ethane is saturated. So from unsaturated to saturated, we know the type of reaction is addition. So still our triple SUUSA is still relevant to this. And then what are the conditions? We will need catalyst for this reaction. We'll need a non-polar solvent for this reaction. So we know that we need catalysts like platinum, palladium, nickel for this reaction to occur. And where are we going to get our hydrogen? We are going to get our hydrogen from the atmosphere. Then I'm not going to discuss the first one, but I'm going to discuss the next one. Let me discuss the halogenation so that we can see how the other alcohol will be formed. Let's say we take an ethene again and we add chlorine water. Then if we take ethene, I will write a structure of ethene so that we can see how addition occurs. Okay, this one is not gonna be there. There are 4 hydrogen, there are 4 bonds around each carbon, and then we add, let's say, Cl2. Then if we add this, we know that ethene, the double bond will be broken. As the double bond is broken, then we'll have missing bonds. Therefore, what are we going to do? We are now going to add this halogen. It means we are going to put Cl and Cl. And if you look at this Cl and Cl, we can see that this haloalkane, this is a haloalkane, is having 2 halogens. So immediately when your haloalkanes are having 2 halogens, you know that, oh, it means this was from the halogenation. I'm going to do an example with hydrohalogenation on the same slide. If we are having again, let me use propene. Propene. I'm using propene, and then I'm okay, and then I'm adding hydrogen and a halogen. Maybe I'm adding HCl, hydrochloric acid. Still in this, The double bond will be broken, and then I will find a saturated hydrocarbon where this one doesn't have any partner because the partner was not there as this bond is broken, and this one is also affected, and then this one is having 3 hydrogen. Is fine. So I must add HCl. Now I need to decide where do I put my HCl. This structure is like this now. Is C, H, and the H, and the bond that is missing. C, H, and the bond that is missing, and then CH3. Let me put it here like this. Okay, just go back. Okay, and this one, and this one. Now, I need to add carbon number 1 and number 2, hydrogen and chlorine. Now, I must now decide, because HCl is like this in a structural form. I must decide where will I add hydrogen and where will I add chlorine. Now you go back to your carbons. You check, as I said in the previous example. When you look at carbon number 1 is having 2 hydrogens, but when you look at carbon number 2 is having only 1 hydrogen. Therefore, it means the one with less hydrogen will take whatever that is remaining, but the one with more hydrogens will take hydrogen. So it means hydrogen will be attracted to where there are more hydrogens. If hydrogen is money, money will be attracted where there is more money, meaning that hydrogen will go here and the chlorine will go here. So that is why as the product that will be from here, the product that will be from here is not going to be a 1-chloro, but it's going to be a 2-chloro, which is going to be our major product that will be formed during this reaction. So when you look at it, it's going to be, the name of the first one that was formed was 1,2 di chloro ethane. I wish I used propane. And then this one now is gonna form 2-chloro propane. Now if we can look at this one, there are 2 halogens. If this one, you look at it, it's only 1 halogen, meaning that if you can see that a halogen like this is having 1 halogen, you can know that it's formed under hydrohalogenation. But if there are 2 halogens, it's formed under halogenation. So I wanted us just to know the difference between the two. Before we go for break, I want us also to look at, let's look at, we already did hydrohalogenation, where we added a hydrogen and a halide, or hydrogen and a halogen. Then the last one is it can be a hydration. I think when you look at hydration, is when we now add water. So there are 4 things that we are going to add, just to summarize. It means we are going to add what? It means we are going to add, let me just go back. It means we are going to add a hydrogen. We are going to add a hydrogen halide, which it can be HCl or HBr. We are going to add a halogen, which is Cl2 or Br2. And we are going to add water. So already from the 4, we know what we are expecting. From this one, we know is hydrogenation. This one is hydrohalogenation. This one is halogenation. And the last one is going to be our hydration. So you must know that there's a difference between hydration and hydrogenation. Hydrogenation is the addition of hydrogen, whereas hydration is the addition of water. What are the expected products? We know here we are going to expect an alcohol when we add water in an alkene. Here we are going to expect a haloalkane. But our haloalkane will have what? 2 halogens. And then here, haloalkane again with what? 1 halogen. And then here is going to be what? The alkane. So already when you have expectations of a product, it might be easy for you. So when we add in terms of hydration, we are going to use the same method that we use in terms of hydrogenation, where we are going to take hydrogen atom will go where there are more hydrogens, and OH will go where there are less hydrogens. Now, we are not going to discuss this, but we need to know the conditions also. We are going to use, in terms of the addition reaction, we are going to use strong acids like sulfuric acid and phosphoric acid for these hydration reactions to occur. Now let's look at elimination reactions. When you look at elimination reactions, we are going to look at elimination, but before we go to elimination reactions, as we are trying to understand and to adhere to the methods that we've used in terms of the addition reactions, we are going to take just a 1 minute break, whereby now when we are going back to elimination reactions, we are going to look at the elimination reactions, how do we eliminate, and also we are going to look at different type of exam questions on how do we answer these reactions. So for now, we are going to go for a little break of 1 minute, but remember, you can still interact with us at 064 748 8913 for us to be able to assist you further with the discussion that we have. Let's go for the break. We have just looked at different addition reactions, and we have also looked at how many addition reactions are we going to be expected to know according to our ATP. We look at the addition reaction of hydrogen, water, hydrogen halides, and halogens. So immediately when you know all your addition reactions, you will be able to know your elimination reactions, because whatever that we have added as part of our addition reaction is what we are going to eliminate. So we are going to look at different types of eliminations. However, for the purpose of the exam and the exam guideline, we are going to look at the first type of elimination, which is cracking. The cracking that we are going to look at is only for the cracking of alkanes. What does cracking mean? It's when the chemical process in which longer a chain of hydrocarbons molecules are broken down into shorter, more useful molecules. This definition is also provided to you on your exam guideline, so you'll just copy it as it is. You'll just remember it as it is. We have two types of cracking. Sorry about that. We have thermal cracking and we have catalytic cracking. So in terms of thermal cracking, we are going to use high temperature and pressure. Catalytic, we are going to use catalyst in terms of cracking. So we are going to take long chain of alkanes, because the cracking that we are going to do is only for alkanes. We don't do cracking for other homologous series, but we will only concentrate on the cracking of alkanes. So we are going to take long alkanes, whereby they will form small useful alkenes and alkanes. Now, the crackings that we are going to look at in terms the elimination that we are going to look at is cracking, which is the first one that I just explained, and the second one is dehydrohalogenation of haloalkanes and hydration of alcohols. Sorry about that. Now, what do I eliminate in terms of dehydrohalogenation? I will eliminate ACl and HBr. Now, when is cracking gonna be possible? When is dehydrohalogenation gonna be possible? These are the conditions. For me to be able to do dehydrohalogenation, I need heat. I also need concentrated strong base. My strong bases can be sodium hydroxide, as an example, or potassium hydroxide or lithium hydroxide, depending on whether you can be able to identify that base as a strong base. So these are the conditions that we need for dehydrohalogenation. Now, remember, dehydrohalogenation came after hydrohalogenation. So the only thing that we've put is the D, because the addition reaction of hydrohalogenation was hydrohalogenation of hydrogen halides. And then if you remove hydrogen halides, you say dehydrohalogenation. So it's hydrohalogenation, dehydrohalogenation. It's like register, deregister, because we are now removing a hydrogen halide in that compound. We are going to look at how are we going to do this dehydrohalogenation. And then the next one, we are going to also look at dehydration of alcohols. Now we remember that in our previous slide, we said alcohols are going to be formed after adding water in an alkene. So if we remove water from this alcohol, it means this alcohol will go back to an alkene. Remember, we started by saying always when an alkene is formed, that type of reaction is elimination. So in our dehydrohalogenation and also in our dehydration, we are going to see alkene forming as one of the product. And also in our cracking, we are also going to see an alkene forming as one of our product. So we need to be able to know that as long as an alkene is formed in a reaction, it means that type of reaction is elimination. Now let's start by looking at cracking. When we look at cracking, we can use different alkanes to do cracking. We can use maybe octanes, whereby octanes will form smaller useful compounds like the ethanes and the propyls. It depends on what, but what is nice about cracking is that you will see what was your reactant and the side of the product. If there's something missing on the side of the product, you will know what is it was on the side of the reactants. Now, dehydrohalogenation, as I said, we need heat, we need a base. However, that base needs to be concentrated and needs to be strong base. Then, in terms of dehydration, we will need excess concentrated sulfuric acid or any strong acid that we are going to use in order to eliminate water from an alcohol, because hydration is when we added water in an alkane and then an alkene gave us an alcohol. So if you want to remove that water from an alcohol, we must now remove it using a concentrated strong base, and it will give us an alkene back, and also the cracking. Now let's look at one example of elimination reaction. Now let's look at remember, cracking, let's take it will always be undergone by the saturated. As I said, only addition will be undergone by the alkenes, which are unsaturated, but substitution and cracking, it will be a saturated compounds. Let's look at dehydration. Let's say we have this alcohol. This is our alcohol. Let's say it's O, and then put H here, and then it's H, and then H, and then H, and then H. Now, this is our butane 2-ol alcohol, and it's our secondary alcohol because the functional group is between two other carbons. Now, when you look at butane 2-ol, how do we eliminate butane 2-ol? We know that from butane 2-ol, if we have to do elimination, we are expecting an alkene to be formed. However, when you look at the number of carbons that butane 2-ol is having, it means now we need to think whether our major product will be but1-ene or but2-ene, because they cannot both of them be our major products. So now, how do we do that? How do we know that our butene is going to be but1-ene or but2-ene? Because remember, the butene give us positional isomers, which is but1-ene and but2-ene. So how are we going to eliminate so that we can see that it's but1-ene or but2-ene that is forming? Now, when you look at our carbon number 1, we can name this one. Is easy to number because our functional group is already in carbon number 2 this side. So it means it's going to be number 1, number 2, number 3, and number 4. So when you look at carbon number 1 and number 4 from our structure, you can see that both of them, they have 3 carbons each. And immediately when they have 3 carbons each, it is not going to be easy for us to take from the richer. If I said, the time I was saying, if hydrogen is money, it means the richest is carbon number 1 and number 4. So it cannot be easy for us to take from the rich. It cannot be easy for us to take from the carbons where they are having maximum number of carbons. The only carbons that are having insufficient hydrogen is number 2 and number 3. Therefore, if we have to do elimination, we have to introduce a double bond. Why do we introduce a double bond? Remember, during elimination reaction, we are going to remove water. And water in our case here is going to be H2O. So we are going to remove H2O from an alcohol. And that alcohol will change from being H2O to an alkene. Now, carbon number 1, we are not going to remove anything in carbon number 1. Carbon number 2 is having an H and an OH. So we are going to remove an OH because an OH will be part of H2O. We are going to remove an OH from this carbon. And then also carbon number 3, we cannot remove from carbon number 4. We can only remove in carbon number 3, and we can only remove one carbon. So it means carbon number 1 and number 2, this hydrogen, we are also going to remove it, and it's going to combine with this one and form water. So water will be formed here as one of the inorganic products. So it means between carbon number 2 and number 3, we are going to introduce double bond so that the two carbons are fully in terms of the carbon bonds. Then we are going to have CH3. Therefore, our product or our major product is not going to be our but-1-ene, but it's going to be but-2-in. That is why we are not going to be able to form but-1-ene in the structure, but we are going to form but-2-ine because the two carbons that are affected are carbon number 2 and number 3. So that is how we do our so we know that it will be but-2-ine plus H2O, because H2O is one of the products that was formed during the dehydration. So this process is known as dehydration. Also, when we do dehydrohalogenation, so we know that in terms of dehydration, we need strong acid. We can use sulfuric acid as our acid must be concentrated, because always we use concentrated sulfuric acid or concentrated bases when we are doing elimination reactions. Then in terms of dehydrohalogenation, we know that instead of maybe OH here, there will be a chlorine here, and the same procedure it will be used also in terms of removing the halogen and the hydrogen in terms of dehydrohalogenation. Also remembering that the conditions for dehydrohalogenation, now they will need a strong base and which is concentrated and heat. But what you must also remember is that what are you going to form during dehydrohalogenation? You are also going to form this alkene, which is but-1-ene, but in terms of the inorganic product, you can form HCl or HBr. Why am I using the two products? Is because most of the time we are using the Cl and the Br as our halogens. So the same method we are going to use in terms of this dehydrohalogenation. In terms of substitution reaction now, substitution reaction, we have seen it when we're doing the substitution reaction of alkanes and bromine water. We used alkane, and then we substituted one of the halogen in an alkane, and there were two products that were formed. So we are going to look at the two types of substitution reactions. We are going to look at hydrolysis of haloalkanes, and we are going to look also at halogenation of alkanes and reaction of alcohols with halogens to produce haloalkanes. So there are three types of substitution reactions that we are going to look at also according to our exam guideline. What is this hydrolysis? Hydrolysis is the reaction of compound with water. So now it means our haloalkanes will react with water to produce what? Alcohols. However, we are not going to use water as one of our reactants in these reactions, because they normally say water takes forever for us to get this alcohol as the product. So we are going to use that. We are going to use diluted strong base. You must know the distinction between the two reactions. In terms of the dehydrohalogenation, which was elimination reaction, our base was concentrated. However, in terms of substitution reaction, now our base is going to be diluted. So we are going to use mild heat or sunlight and diluted strong base in terms of the hydrolysis, where we are going to form what? Alcohols from where? From haloalkanes. And then we are also going to use to do the alcohols producing haloalkanes, and we know that we are going to use our hydrogen halides to do that. And then we are also going to do halogenation of alkanes, where we are going to add this one. We have already done it in our testing for saturation. If you want to know how is it done, you can go back to the testing of saturation and see how is it done. Remember, learners, we can do any let me just I just want to go back a little bit. We can do a substitution or hydrogenation of any compound, whether that compound is sometimes whether that compound is branch or not branch, because it is very important to know that sometimes when the compound is branch, okay, let me just try and put it, I want to, because if the compound is branched, then it means we need to be able to, this thing doesn't want me, okay, let me just try and do this and erase all. When our branch, when our compound is branched, sometimes it might be difficult for us to know which one do we use, which one, how do we eliminate. Let me use this example. For example, this one, I'm just going to do eliminate. I want to do elimination because I think I forgot to show you how do we eliminate when we are having a branch, which is very important. And then I'm putting our OH again here so that you can see how will the alkene now form. Substitution is not a problem. The only problem is that you need to know the conditions and how do we substitute only. Now, if you can see at this structure, if you name this structure, you can see that we have an OH and so this structure is having two things, two substituents, the branch and the functional group. So we always know that when we have a branch and a functional group in a structure, we know that a functional group will always take a preference. So in terms of numbering, it's going to be 1, 2, 3, 4, and 5. So the name of this what is it, alcohol, is going to be, this is 2 dash, it's 4 dash dash methyl, then 1, 2, 3, 4, 5 pentane dash 2 dash all. So this is 4 methyl pentane 2 all. So how do we do then the elimination? When you look at this, you can see that now when you look at this one, when you look at this one is not gonna, remember when you do elimination, at the end of the day you must find an alkane, and the first thing that you must remove is the OH, because it's the functional group of alcohols that will make you to be able to find the hydrocarbon, which is an alkane. So you'll remove the OH from this, and then immediately when you remove OH from this one, you go to the next one and you remove what? The H. You will not remove anything in carbon number 4 and number 5 and number 1. So how will the structure look like? The structure will be, this one was having CH3, we don't remove it. However, carbon number 2 now will be left with 1 hydrogen, and then we introduce a double bond with carbon number 3. It will also be left with 1 hydrogen. And then in this one, there's a hydrogen and a branch. You leave the branch where it was. You don't tamper with the branch and CH3. Therefore, what is the name of the alkene that will be formed? Of course, our double bond is in carbon number 2 again, between carbon number 2 and number 3, which is carbon number 2. So it means it's going to be still 1, 2, 3, 4, 5. So instead of getting this one as carbon number 2, but our carbon number 2, it will still be in carbon number 2, 4. So it's going to be 4 methyl pent, then dash 2 dash in. So this is how we do elimination. So the branches must not be a problem for you to do elimination. We know that at the end of the day, we are expecting an alkene always to be formed in an elimination reaction. So a branch is not an issue. Now, so when you do substitution, we know that we are going to use, like, let me go back. We are going to use haloalkanes in order for them to give us what? Let me erase all. We are going to use haloalkanes in order to give us the alcohols. So if I have maybe the chlorobutane, or let me use Br for now because I've been using the chlorine for some time. And then now on this one, I must have 2 reactants, because remember, I'm looking for an alcohol. I cannot find an alcohol from the bromine. So it means now I must add maybe sodium hydroxide. And I know that it must be in aqueous or it must be diluted. So sodium hydroxide will react with this haloalkane to give me what? To give me an alcohol. Let me extend. To give me an alcohol. So wherever there was OH, there will be, wherever there was Br, there will be OH. So it means the alcohol that will be formed is going to be the 2 all, as you see from this one, OH, and then CH, then CH2. Let's try. Okay. Then plus. Remember the Br was removed from this, and the Na from sodium was also not used. So it means the other inorganic form a product that will be formed will be NBr. So the main thing that you need here as your condition is mild heat and the diluted sodium hydroxide, because I've used sodium hydroxide as my example. So this is how we are going to do. If it can happen that you use concentrated sodium hydroxide in this specific reaction, you are not going to get an alcohol. You will go back and get an alkene, because what will happen is the dehydrohalogenation, because the condition for dehydrohalogenation needs a concentrated strong base. But if you want to form an alcohol, you must use that sodium hydroxide. It must be in water, it must be diluted in water, so that you can get an alcohol. So the reaction conditions are very important. And for the dehydrohalogenation and the hydrolysis, because the name of this reaction is known as hydrolysis. What is hydrolysis? Is the reaction of what? Of a salt with water. So when we are doing hydrolysis, because water is present here, an alcohol will be formed. This is the only example of a substitution reaction that is given name. Otherwise, other examples won't be given name. They are just referred to as substitution reactions. Now, okay, let's look at this diagram. When you look at this flow diagram, the flow diagram below shows various organic compounds that can be prepared using compound P. So compound P, we don't know what is it. We don't know whether it's saturated or unsaturated. And then we have compound Q. And then we have, but when you look at reaction 1, you can see that there are two products formed. And immediately when there are two products formed like this in compound 1, something will come into to say, but now if there are two products formed and one of them is an alkane, this one is an alkane because it's C5H, it's an alkane and compound Q. I wonder what is it. But when you look at compound Q, it will undergo bromination, okay? And it will form compound R. And then it will also undergo hydrohalogenation. What type of reaction is this? This is addition reaction. Which compound did we say it undergo addition reaction? We only said only alkenes according to our syllabus. So we can easily identify compound Q as an alkene. So already we know that, okay, so if compound Q is an alkene, it means now reaction 1, it means it's from a certain compound to an unsaturated. I said to you, always when an unsaturated compound is formed, it means the type of reaction is elimination. So we know that reaction 1, we already identified reaction 1 as elimination from this hydrogenation that will be undergone by the, because this one never reacted with anything. So it was not an important product that could continue to form other reactions. And then, so this alkene, even if we don't know what is the name of the alkene, but we know that it will form 1, 2, 3. It will form a haloalkane with 3 carbons. Therefore, what is the name of an alkene with 3 carbons? Is what? Propene. So we have already identified this alkene as a propene, which will give us the 2-chloropropane. And then this 2-chloropropane will undergo hydrolysis reaction. By the way, when is the hydrolysis reaction occurring? Is when a haloalkane reacts with a diluted strong base to give you an alcohol. So we already know that this S is now an alcohol. So if this is an alcohol, this is going to be our substitution reaction. So we can identify all these reactions. This one we have identified it as addition, this one as elimination, this one as substitution. So you'll always have, and then this one, because it's an alkene forming with an alkane, it means this one is going to be what? Is going to be our cracking from a larger molecule to a smaller useful. Now, how do I identify my compound P? I already know that there are 5 carbons here, and I already know that there are 3 carbons here. So if there are 5 carbons and 3 carbons, 5 plus 3 give me 8. So it means I already know that this is going to be octane, which is having 8 carbon chain, which is an alkane with 8 carbon chain. So from the understanding of this reaction, you can be able to even further identify your reactions. So from there, you can be able now to answer your question. So I will always urge you not to rush to the questions. Just start by looking at the structure first and see whether you can be able to identify and find the links or the clue in terms of your reactions and be able to identify your reactions. So the first thing that is saying, Write out the meaning of hydrohalogenation. We know is the addition of hydrogen and halogen in an alkene. And then write down the structural formula of Q. Already, if you have identified them, you will be able to do that, to write the structural formula of Q, which is provided to you. Let me just go back. The Q structure is this one and is propene. So already you'll know how to write the structure of propene, which is, we will always look at the double bond. And then it will say what type of elimination reaction is that one. Always check what is it that you have removed from that. And sometimes if maybe you are not sure, like let's say you are given a propene, like a propene is formed like this. If you are not sure, you just subtract the number of carbons and the hydrogen from both sides. You will see what is it that was removed from that structure. Maybe let's say you're having a propane and then you end up having a propene. You will see that there are two hydrogens that are now missing on the side of the product. Then you will immediately know that that was the dehydrogenation, or if the water is removed, that was hydration and all that. So the number of carbon side on both sides, they are very important. And then write down the IUPAC name of R. I think we can do that because we've identified R already. For the hydrolysis reaction, write down the balance equation using a structural formula. The examiner sometimes will say use structural formula, sometimes use the condensed structural formula, sometimes use a molecular formula. So it is very important to follow the instructions according to the way the examiner is asking you the questions. And then two reaction conditions for hydrolysis. We know that the two reactions for hydrolysis, we know we need dilute, strong base. You can just name the base if you know it, and mild heat. If you don't know, if you have forgotten mild heat, you can just use sunlight, because also sunlight is mild heat. When you look at this one, you can see that we are starting with an alkene because of the double bond, and then it reacts with HBr. I think we already know now that when an alkene reacts, it will always undergo addition reaction. So because this alkene reacts with HBr, it will form a haloalkane. We already know that. And because there's a haloalkane, we'll have what? We'll have one halogen. So a haloalkane will be formed here. And that haloalkane will further, in terms of, with sodium aqueous. Aqueous means diluted sodium hydroxide, and give you Y. So already you know that if this is an alkene and it gives you a and it reacts with HBr and give you a haloalkane, when it reacts with diluted sodium hydroxide, it will give you what? It means this Y is going to be our alcohol. So they say identify the formula of Y. How can we identify the formula of Y? We know that if it was propene, it means we're going to have a propane. And the bromine will be in carbon number 2. So if the bromine is in carbon number 2, it means also the OH of the alcohol will be in carbon number 2, which is going to be this one. The OH will be here. So we're going to get propane 2-ol. So these are three reactions in one. It's from the alkene, and the type of reaction here is addition. And then this one to this one is going to be substitution, because as we are going to have a haloalkane is saturated and alcohol is also saturated, so the type of reaction is going to be a propane. It's going to be substitution, so we are going to get propane 2-ol. So if we have to identify, we have to identify as propane 2-ol. And then this one is about addition reaction of hydrogen. Obviously, we are expecting compound Y to be an alkane, and the only alkane that is present here is number D. So those are the things that you need to look at, but you cannot know that if you haven't read the first instructions that are given to you in terms of what are you expecting as a reactor, what are you expecting as a product, if this is the reactant and if this is the type of reaction. So all what we did in terms of how this addition reaction occur, in terms of adding hydrogen, halogen, hydrogen halides, and water, this will assist you definitely to identify different products that you are expecting in terms of multiple choice or in terms of reactions. Then this one, it says this one is also giving you a flow diagram. This one now is using a branched alcohol. Now, what you're going to do here, compound P is used as a starting reactant in each of the two reactions. I wish we can do this up to the end. Now, when you look at compound P, we don't know what is compound P, but we know that it's having 5 carbons, 11 nitrogen, and a bromine. So it can be something of a haloalkane, because we don't do haloalkanes, but we don't know whether it's a straight chain haloalkane or it's a branch haloalkane. However, when you look at reaction 1, you can see that when this haloalkane reacts with dilute sodium hydroxide, you are getting an alcohol, and that alcohol is branched. So already you can see that if the alcohol is branched, it means the haloalkane is also branched, because it means this haloalkane must produce an alcohol with the longest chain of 4, whereas it's having 5. So one of the carbon of that haloalkane is branched. Then you'll know that, okay, so this is haloalkane is saturated, and it's giving me alcohol which is also saturated. So reaction 1 I know is substitution. But this substitution reaction, because it's the reaction with sodium hydroxide in water, it is not just substitution but is hydrolysis. And another condition is that it needs mild heat. But when you look at reaction 2, you see now that the sodium hydroxide is now concentrated. So if the sodium hydroxide is concentrated, already you know that this is an elimination reaction, because the condition is concentrated. Here it was diluted, substitution, concentrated is elimination. And in elimination reaction, what are you expecting? You must get an alkene. And obviously that alkene will also not be a straight chain alkene, because it is coming from a branched haloalkane. So it will also be branched. And then when you know that this is an alkene, it means the reaction 3 is already addition, because always addition is coming from alkenes. So you know that this product is going to, because we are going to add HBr, we are going to find another haloalkane. So I haven't looked at any question on the exam, but I've just looked at what is it that I'm given and what is the information that I have in terms of these reactions, in terms of what they are coming from and where they are going. Now, reaction 1, 2, and 3 represent organic reactions. Name the type of reaction represented by reaction 1. So reaction 1, we have identified it as substitution reaction or hydrolysis, because it's from saturated to saturated. And then, is 2-methyl-butane 1-ol a primary, secondary, or tertiary alcohol? From the information that we know from the primary, secondary, you need to draw this structure of 2-methyl-butane 1-ol. So if it is 1, 2, 3, 4, it means in carbon number 1 we have an OH, and then in carbon number 2 we have a methyl. So you can be able to identify it by drawing a structure. So if you draw a structure, now you'll see the COH is bonded with 1 carbon. So you can see that this is going to be our primary alcohol. It doesn't mean that always when you have a branch, you will have a tertiary alcohol. Sometimes a branch will not affect the carbon with an OH. So therefore, it will not make it to form a tertiary alcohol. Give a reason for your answer. The carbon bonded to a functional group is bonded to one other carbon. And then write down the structural formula of compound P. Compound P, we have already drawn the structure of it. As we have seen that this one is an alkene, and this HBr will be formed. Obviously, this one will have a branch. However, our alkene now is going to have a branch. So you will check where the branch is, and then put the Br where you remove the other number of carbons. So you'll do an elimination reaction from this haloalkane or from this alcohol, in order to see how do we do elimination in terms of the branches. I think I have shown you how do we do the branches, how do we do elimination where we have a branch and the functional group. And then name the type of reaction represented by 2. We have done that is elimination reaction, and the reason is because we have seen it by the concentrated strong base. And then to which homologous series does compound Q belong? We have identified it as alkene. And then name the type of reaction represented by reaction 3. We said is addition, because an alkene will always undergo addition reaction. And then they said choose from addition, elimination, or substitution. So we have chosen addition in our case. And then write down the IUPAC name of compound R. So compound R is going to be from this alkene to this haloalkane. Using what? Is going to be hydrohalogenation, because we are going to get the hydrogen halide into this alkene to get compound R. When you look at this one, 1,2 bromopropane can be prepared from butene. Now, a 3-step process. These days, you will find that we are expected to know how do we move from one a reaction to another. So you must know all the type of reactions, and you must know the expectations of all the type of reactions. Like for example, when you look at butene in step 1, giving you compound A. Already but2-ene will react and form addition reaction. That one I think we already know. And then we don't know but what is the type of addition reaction, because we don't know what is added. And then compound A will be formed. And then step 2, compound B is formed. And then step 3, we find that 1,2 dibromopropane is formed. You see, from but, which is having 4 carbon chains, to prop, which is having 3, it means somehow compound B was formed with another product, but that product was not carrying over in terms of making other products. So it was ignored. So it means from step 1 to step 2, step 2 to step 3, we can be able to identify step 3. How are we going to identify step 3? Is 1,2 dibromo. I said to you, when there are 2 halogens, it means there is halogenation. So if it is halogenation, it means this halogenation is coming from this. And how many carbons were there? There were 3. It means this was a halogenation of what? Of propene. So it means compound B is propene. How did I identify that? How did I track that? By this prop. Then what is it that I'm going to add here? I'm going to add Pr2. How do I know? Because they are dibromo. As this propene is going to undergo addition reaction, is going to break this double bond. And so don't be confused when you see you started with 4 and you add with 3. It means this product as didn't carry on in terms of reacting, but this compound B carried over in terms of reacting with other compounds, and it produced this. So if this is a propene that was formed, then we go back and try to identify it. We know that butene undergone a reaction, and then if butene undergone a reaction and form compound A, for compound A to go here, it means it must undergo elimination reaction. So it means for this reaction, it means an alkane was formed here. And if the alkane was formed here, it's a, because this already shows that this is cracking. For the method that we have seen that these 2 products are formed and one of them is an alkene, it means this is cracking and this is an alkane and this is an alkene. So here it means there was a cracking of alkane. And what is an alkane that is having 4 carbon atoms is butane. So butane here will form what? Propene. And what? And one of them will be what? Will be a methane. But methane never reacted further, so that is why it was ignored. So the examiner wants the learners to know the condensed structural, using structural condensed structure, write down the balance equation for reaction 1. And when you say condensed, learners, you know we mean condensed. You cannot write a structural formula if you are expected to draw a condensed. So you will draw a condensed structural formula to do this addition reaction, which is hydrogenation. So you'll do an addition reaction of hydrogenation, which is 4 marks. And then you also need to indicate the reaction conditions. We know that the reaction conditions of hydration, we need a catalyst in the presence of this reaction so that this reaction can occur in terms of the condition. And then write down the type of reaction in step 2. And already we know that is elimination because an alkene is formed, but definitely this is cracking. So you can say cracking or elimination, both of them are acceptable. And then write down the IUPAC name of compound B. Compound B, we have seen that is propene. Guys, you must make sure that you don't say prop1-ene, because propene doesn't have any positional isomer. It's just propene. Even ethene is not eth1-ene, it's ethene. So where you don't have positional isomers, you must write as correct as it is. It's just propene. And then using a condensed structural formula again. So you need to know how to do the condensed structural formula from our previous lesson. Using a condensed structural formula, write down the balance equation reaction 3. So reaction 3, of course, is that one of a propene reacting with what? Reacting with a halogen, which is a bromine. Now, I will always say just use a structural formula first, and then you know that the condensed will be CH3, CH, and then CH2, CH3, and then plus Br, and then it will give you this brom. But all of them, they must be in a corner structure. So learners, as we started today, we looked at different compounds and we classified them as saturated or unsaturated, and we're also able to identify our saturated compounds and our unsaturated. We look at how do we test for saturation. We look at different types of addition reactions one by one, looking at how do we add and what is it that we add and what are the products that we expect when we add. We looked at different elimination reactions and how do you do elimination in a structure where you have different carbons with different hydrogen. So make sure that always when you are asked a question in terms of a flow diagram, look at the flow diagram first. Try to analyze the flow diagram first before you go to the questions, because the questions will always be there, but the understanding of the reactions according to the strategies that you use, strategies like triple S, SU, USA, they are very important. So from here, I think you will need to go back to your notes again and try to find out what is it that we have done today, and make sure that whatever that you didn't understand, you go back to your teacher and you let your teacher to make you understand this concept. Thank you so much for watching this lesson. Please remember to sanitize, wear your mask, maintain your social distance, and till I see you next time in our next lesson. Goodbye for now. Thank you.